All right, example 4 for squares. It says, what is the most specific name we can give this quadrilateral? So we have to inspect what is marked and do the best we can. So things that are given to me is that we have 4 congruent angles. And so if we have 4 congruent angles, think about your flowchart if you want to pull that out. Look and see where is the first time you see 4 congruent angles mentioned. Let's see if I can pull mine up. I think it is here. So 4 congruent angles. So is it a parallelogram? Do we have 4 congruent angles here? No, it's definitely not a kite. Oh, looky here. Rectangle has 4 congruent angles. So it's going to be a rectangle unless we see anything else marked. So let's take a look. There we go. So I don't see any sides marked. I don't have any other information given to me. So the only thing I can say is that this is a rectangle. I have no information to prove that it's a square or anything else. So the most simple name, most specific name I can give it is rectangle. Okay. Looking at example 5, we're going to do the same thing. Try to decide, based on its information, what I have. So what is the most specific name? So what I'm given is 4 congruent sides. Now, parallelograms, you have 2 sets of congruent sides. They're on opposite sides, but not all 4 have to be congruent. And then rectangles obviously don't have 4 congruent sides because you can have a longer side of your rectangle. And I don't know anything about the angles, so I can't say it's a square. So if you want to glance at your flow chart again, go look and see where it says what this might be. But I'm going to confidently state that this is a rhombus. Based off the information, I cannot say it's anything else. All right, let's get some more square practice in. Okay, I have square ABCD. It says DO is 7. So DO is 7. What is AC? So remember, all of these are congruent. So if DO is 7, then AO is 7, and OC is 7. So AC has to be 14. And it says, what is the measure of AOD? AOD, so this angle right in here, which is at the intersection point of our diagonals, that is a right angle. They meet at a perpendicular. So the measure of AOD is 90 degrees. And then OBC. OBC, this angle right in here. Well, our diagonals bisect the angles in a square. So 90 degrees bisected is going to give us the measure of angle OBC being 45 degrees. So the only angles you're ever going to see inside of a square, 90 and 45. That is it. So that should be a very solid, lock that in. There's no question. It could be something else. So let's look at these little words. I have something that says a parallelogram is a blank if and only if its diagonals are perpendicular. So we have to think about what shapes have perpendicular diagonals. That is a parallelogram. There's only 2. One is a rhombus and one is a square. And it says if and only if. That means it has to work in both directions. So it can only be a rhombus if its diagonals are perpendicular, and it can only be if it has diagonals that are perpendicular, it has to be a rhombus or a square. But remember, a square, look at your flow chart, your square uses everything from a rhombus. So a square is technically a special rhombus. So a rhombus is our answer. Our second problem says a parallelogram is a blank if and only if its diagonals are congruent. If and only if its diagonals are congruent. So think on your flowchart. Where's the first place you see diagonals that are congruent? Under parallelograms. Do not look at the isosceles trapezoid. Yes, those diagonals are congruent, but that is not what we are looking at. We're talking about parallelograms. So under parallelograms, parallelograms themselves don't necessarily have congruent diagonals. Rhombuses definitely do not. Squares do, and so do rectangles. But just like on our previous question, a square is a special rhombus, just like a square is a special rectangle. So we're going with the one that claims it first, which is the rectangle. Okay. Look at one last group of examples, and then we are done with chapter 6, except for a little bit on graphing, but that'll be not new information. All right, it says Miss Ernest is drawing rectangle ABCD. Determine whether the following statements are always, sometimes, or never true. So she's drawing a rectangle. It might help you to draw a rectangle to give yourself something to mark up to test to see if these ideas are true. So, always, sometimes, or never true if this is a rectangle. So angle A and angle C are congruent. Well, yeah. They all have a measure of 90 degrees, so they're always going to be congruent. Also, it's a parallelogram, and opposite angles are always congruent inside of a parallelogram. And then we see B says AB is congruent to CD. We're going to go with always here as well. Parallelograms have opposite sides that are always congruent, and a rectangle is a parallelogram, so that has to remain true. And then AB is congruent to BC, so these are two sides that intersect. This is something that can be true for a rectangle if it is a square, so it's sometimes true. And then we have a diagonal AC bisects angle A. So if I drew a diagonal across, could it bisect angle A? It could. Does it always? No. So this, again, is a sometimes. And that sometimes means that it's going to happen when it's a square. Now it says AC is perpendicular to BD. So that's saying the diagonals AC and BD are perpendicular. So again, that's not something required for a rectangle, but it sometimes happens when it's a square. And then lastly, if AD was 8 and AC was 10, then AB would be 6. So that sets you up with like a little triangle. So that would be 10, 6, and 8. So we can always check that by doing Pythag. 8 squared plus 6 squared should equal 10 squared. That is always true because that is a Pythagorean triple.